Okay, the next part we're going to talk about, and I think this is the last part of the unit. Yeah, that's it. So we're getting close to the end here. The last part is called complex rational expressions. And basically what it looks like is a fraction over a fraction. Okay, so basically it's just kind of a way to scare you a little bit. At the bottom of page 12 in your notes, it shows some examples of them. A complex rational expression could have a fraction in the numerator, it could have a fraction in the denominator, it could have it in both. Okay, that's what it basically says. Okay? So let's basically see how to do this. And the first way that you can solve complex rational expressions, and really the main way, is to basically get rid of the denominators again. But let's take a look. So the first one we have is 3 over 4 plus x over 2 all over x over 8. Okay, and if what you do, the thing you'll want to do initially is you will want to look to find, you'll kind of try to break these into two different sets of fractions. So really look at this as like that fraction in the middle as really kind of a divider, and you have fractions on top and a fraction on bottom. Okay, and what you want to do is you want to look to find what is the common denominator of all the fractions. Okay, so just like we were doing in the last part of the rational equations, you want to find the common denominator of everything. And then what you're going to do is you're going to multiply both the top and the bottom by that common denominator. Okay, so in this case, if you look, you have the denominators of 4, 2, and 8. So what do they all have in common? They can all go to 8, right? Okay, and what you're going to do is you're just going to distribute it to everything on top. So everything gets multiplied by this 8 up top, and everything gets multiplied by this 8 on the bottom. Okay, so that's what you're doing there. I'm going to erase this little part because it got a little messy. But that's what you're doing. You multiply the top and bottom by the same thing to get rid of your denominators. Okay, and when you distribute this in, what do you get? Well, 8 and 4 cancel, so you get 3 times 2, and that becomes 6, right? So 3 times 2, because the 4 and the 8 cancel, and that becomes 6, and then the 2 and the 8 cancel to become 4, so you get 6 plus 4x over, let me erase this, 3 over 2. Okay, and then 8 and 8 cancel, and they just become 1, and so that becomes x. Okay? And really, in this case, that's all you can do. Okay, there's nothing else to do. You could factor out a 2 out of the top if you wanted to. You could make this 2 times 3 plus 2x over x, but there's nothing to reduce, so you could leave it either way. Doesn't really matter. Okay, but that's it. You're finding a common denominator of all the fractions, and then you're distributing it to everything. Okay, and that's how you're going to get rid of it there. All right. So let's look at example 2. All right, example 2, you have 1 minus 1 over x all over 1 minus 1 over x squared. Okay, so where are our fractions? We have 1 over x squared and we have 1 over x. So what's our common denominator? Okay, it's going to be x squared, right? Let me get rid of my, see if I can get rid of my, oh I can't, oh well. So anyway, our common denominator will be x squared, right? So we'll do 1 minus 1 over x. We're going to do all this times x squared over 1 minus 1 over x squared all times x squared. Okay, so by the same thing on top and bottom. So now we distribute. So x squared times 1 is x squared. And then x squared times 1 over x, your squareds cancel, right? So that goes away, and you're just left with minus 1x, or just minus x, right? Okay, and then on the bottom, x squared times 1 is x squared, and then your x squareds cancel, and you get x squared minus 1. All right? Now, here we can actually factor. Okay, let me see if I can get rid of that one. You can, okay. So now we can factor, right? On top, we have x in common, so we get x times x minus 1. And on the bottom, we have a difference of two squares, x squared minus 1, so this becomes x plus 1, x minus 1, and then our x minus 1's cancel. Okay? Let me shrink it down, give myself some room. And so, what's our final answer? We get x over x plus 1. There you go. There's your final answer. Okay, so it's all stuff you already know how to do. You just have to kind of put it all together now and really pay attention to what you're doing. Get rid of denominators, okay, and cancel when you can. All right, so let's keep moving along. Okay, so hopefully this worked out. I had a little malfunction here with my program, so hopefully it's just at the beginning of this problem. So we have 4 over x squared minus y squared over 2 over x minus y. Okay, and what we're looking at is a different way of showing this. What I'm going to do is I'm going to rewrite this problem, and because really it's just dividing two fractions, right? And so I'm going to rewrite this now as dividing two fractions. So 4 over x squared minus y squared divided by 2 over x minus y. Okay, and hopefully you remember that when you're dividing fractions, what do? You copy dot flip, right? Okay, so 4 over x squared minus y squared times x minus y over 2. Okay, so this is a different method to solve these problems. Now, we're still in the same boat. We still have to do our factoring and stuff. So over here on the bottom, okay, x squared minus y squared, that is a difference of two squares, right? So that becomes x plus y and x minus y. Okay, and I'll bring everything else down. Alright, and now I can cancel. Okay, so my x minus y's cancel, and then my 4 and my 2 also cancel, and then everything's gone, so I'm left with 2 over x plus y. Alright, so that's a different method to solve these problems with too, a copy dot flip. It's up to you which way you choose. Sometimes some of the problems get kind of complicated when you go to do this copy dot flip thing. So just be really, really careful in which ones you choose. It's when it's really simple like this, easy factors, you can go ahead and do that, but just be careful. All right, so at the bottom, page 14, we have some try these. Give those a shot. All right, so the first one, we have x over 2 plus x over 3 all over 1/2. All right, now this would not be a very good example for our copy dot flip. So what I'm going to do, because finding a common denominator for this is pretty simple, I'm just going to multiply everything by 6. Okay, and that will get rid of our denominators. Okay, and if you wanted to like kind of show this a little bit better, you can put a little times 6 for this thing as well. Okay, it's up to you. So those cancel, it becomes 1 and 2. Those cancel, it becomes 1 and 3. Those cancel, 1 and 3. So now we have 3x plus 2x all over 3. Okay. Then you combine those, you get 5x over 3. And that's all you can do. You can't do anything else with that. Hopefully I didn't make any mistakes there. Got a little messy. All right. So that one's pretty simple. Let's keep moving on. Okay, next example. Okay, again, not a very easy candidate for flipping. So let's just go right ahead and multiply everything by common denominators, which would be x squared. So we'll multiply top and bottom by x squared. There we go. Okay, and we're going to distribute. So x squared times 1, x squared plus, and then our x cancels out the squared. We're left with x. And then we have x squared minus, those cancel out, minus 1. Oh, that looks a lot like our example we did earlier, huh? Alright, so then we factor. We get x times x plus 1 over x plus 1, x minus 1. And those cancel. So we're left with x over x minus 1. There you go. Pretty simple. Alright, let's keep moving on. Okay, this one might be a good example for flipping, so let's look. 3 over x plus 2 and 2x minus 1 all over x plus 2. Okay, so let's rewrite it, because what you're looking for here is you're looking for easy factors that are kind of multiplied by each other. Okay, and if you can do that, if you can find that, then it'd be easy to flip. So here we're going to do this. 3 over x plus 2 times 2x minus 1. And then we're going to rewrite this as x over x plus 2. Then we'll do 3 over x plus 2 times 2x minus 1. And we'll copy dot flip. So x plus 2 over x. So our x plus 2's cancel. And we're left with 3 over x times 2x minus 1. And that is it. That is the last notes for Unit 7. Hopefully this is all making sense to you. Let me know if you have any questions. Make sure you go back through everything and do all of your work before you take your unit test. Good luck. Move this. Oh.